All righty. Well, let's get going. Welcome everybody to Defender Fridays. My usual pitch. This is really just a case that we get to chat with all kinds of interesting people in cybersecurity, and we just want to make that circle bigger. Expose folks to things that maybe is not what they do day to day, but always the defensive side of cybersecurity. Um, so this is not meant to be just like a slideshow. This is really kind of a conversation. And today, in fact, it's also a little bit of a demo time. So that's cool. So we've got Zane with us today. Hey, Zane, do you want to maybe give a quick intro?
Yeah, definitely. So, hey everyone, thanks for having me on Defender Fridays. I've been listening for a long time, so real honored to be on here this week. And I've been doing cybersecurity around 7 years now, mostly in manufacturing companies. So, lead a small team. We kind of cover the whole gambit, everything from compliance to detection and response. So, got all the same problems the big organizations have, right? But yeah, no, today I'm here to talk about Honeyfiles. So, really excited to talk about that. And Honeyfiles, I've always been excited about it because I think as defenders we have a home turf advantage that a lot of people forget about. So we get to control our environment, before the attacker comes in. We get to know our environment really well, so really good asset management, kind of all those basics. But then we can also lay tripwires, um, in place to catch adversaries, and that's exactly what we can do with Honeyfiles, which I think is really cool. Now,
Love
honey
that.
files, they've been around. Sorry, go ahead.
No, no, no. Go for it. Go for it.
Yeah, yeah. Honey files, they've been around for a long time, so that's nothing new. Uh, I think one of their earliest uses is if you look at like Clifford Stoll back when he presents in his book in Cuckoo's Egg, kind of one of those classic books I think everyone in cybersecurity should read. But he places a bunch of fake military documents in order to get the threat actors to stay connected long enough so that he can work with law enforcement to get the warrant to uh, trace back that threat actor to Germany. So been around for a really long time. Um, but I think with Velociraptor, amazing tool if you're not familiar with it, free, open source. We can make some real improvements from the classic way of doing honey files in Windows and really solve some of the tough problems that came with kind of trying to deploy them and also monitor them. Really excited about that. And that's what I'm going to demo here in a minute here. But yeah, I don't know. Any questions, Max? And I could give a little background more on honey files as well.
Yeah, no, I mean, I'm personally very excited because I feel like, and it sounds like that's kind of the sweet spot you're going to hit. It's a fairly well-known concept for a lot of people, but as so many things in cybersecurity, going from the concept to actually deploying this in production in an enterprise, like there's a big gap. So yeah, I'm looking forward to seeing how to do that practically. So yeah, like take it away, man.
Awesome. Yeah, very cool. So yeah, I'll just give a little more background. Honey files, the classic way to do that in Windows, who anyone's done that before, um, is to set up file auditing on the computer. So it's normally done through group policy. You have to configure that computer to actually monitor file events. Then you have to craft your honey files. You have to go in and actually make believable files that you think the attacker would be interested in because you're looking to catch them in like privilege escalation, in lateral movement. They're looking for things like SSH keys, like password vaults. They're looking, and also the data that they're actually, those crown jewels they're looking for. So whatever that is. So you need to tailor and build up those honey files. Then you need to place them on your endpoints. And then finally, you can monitor for event ID 4663, which is object access. So there's quite a few steps in that process. And what we could do with Velociraptor is we could condense that all into one step, which is just, all you have to do is use the artifact I've built in Velociraptor, and you can deploy that out to many clients all across your organization, all in one shot. So I think that really solves that tough problem there, which was, actually the deployment and then also the collection. of the events. What's really cool.
Sorry, keep going.
That's what's really cool about Velociraptor in particular is when we look at file access in Windows, it's kind of a hard, tricky thing to get. So if you take, for example, Sysmon, I think a lot of folks would be familiar here with Sysmon. You get file create events, you get file delete events. You don't get file access events. A lot of your EDRs don't have file access events either because it's just such a noisy piece of telemetry that they're not going to collect it for you. So what that leaves you with is really that 4663, which, again, you're going to have to configure per endpoint or through group policies. And the event you even get out of that, it's not going to have much besides the process that accessed it, as well as, that file that triggered that detection. So not really all the context we'd want there. But with Velociraptor, sometimes I think I just take this for granted as a normal everyday user of Velociraptor, but you can tap into Event Trace for Windows, which is a really verbose log source. And specifically here in the Honeyfiles artifact, we're using the Microsoft Windows kernel file ETW provider, Event Trace for Windows provider. And what that lets us do is see file access. So really cool there because there's not really many ways to get file access at scale reliably as a defender. And Velociraptor lets us do exactly that. So yeah, just really powerful. So I'll jump into the demo here. I do want to say before I jump into this, for anyone with more of that red team mindset, there is ways to bypass this. And I think it's important we understand the limitations of the detections we put in place. So if you're looking at something like using raw NTFS file reads, using the master file table, you're using volume shadow copies, there are ways to bypass this. But I think anytime we can, make an attacker question something as simple as just reading a file, that's a win for the security team. And then hopefully we force them to make mistakes or to trigger other detections as part of our defense in depth strategy. So yeah, I think with that, unless there's any questions, I can move on to the demo here.
Go for it. I know one part that I'm curious to see as well is the read part of this, meaning I would expect that, the file read events, you're going to get a ton of random like Microsoft indexer, OneCloud, whatever, like triggers every 5 minutes. So I'm curious to see your strategy about that. Go for it.
Yeah, no, totally. And we're going to get into that. I actually made an adjustment to this artifact this week, and Mike Cohen pulled it into the artifact exchange, and I think it helps us kind of tune out some of that noise. So excited to talk about that as well. All right, so let me share my screen here. All right, can you all see that?
Yep.
Awesome. All right, so here in Velociraptor, if you're new to Velociraptor, this is up on the artifact exchange. So the first thing you're going to do is you're going to come here and you just need to import the artifacts from the artifact exchange. So you're going to run the server import artifact exchange. You would just come in here, select this, you'd launch it. That's how you would get this Honeyfiles artifact. Once you do, it's going to be in our artifacts tab here. And we have our Windows detection Honeyfiles artifact. So we actually have a Linux variant too that uses eBPF for detection. But today what I'm going to be demoing is the Windows variant. So once you import it, you'll have this available. And then all you need to go to launch it is you're going to come over here to the client monitoring tab. We're going to update the client monitoring table. For this, I'm just going to select all for this demonstration. You're going to make sure this detection Honeyfiles is checked. And now you can come in here and you can customize these Honeyfiles exactly to your environment, to what you want to detect. So we can see all the default Honeyfiles we are going to create here. And it's going to create these for every user on the system. So not just for a single user, for every user. And for example, in this first Honeyfile here, we're creating a fake KeyPass password manager database. And KeyPass is often targeted by threat actors because it contains all those sensitive secrets. So all we have to do here to make this fake Honeyfiles, we just add it here. We're going to make sure it's enabled. We're going to add some magic bytes to the beginning. That way it looks a little bit more believable for the threat actor. If they were to run like the file, pull it back to their system, run the file command in Linux, it's hopefully going to match up with what they're expecting. And then right here through our artifact, we can pad it. We can expand it and bloat that file out with a random number of bytes so we can make the size more believable so that it's not too small. If we want to add something new here, we can just press the plus sign and we can add, a new Honeyfile. So I'm going to add, Claude Code has been all the rage. Maybe someone's after our Claude Code secrets. So I am going to add a Claude Code Honeyfile. So let's add the .claude folder and we'll call it settings.json. We're going to set it to enabled. I'm just for this demonstration, I'm going to copy some random magic bytes. Just choose a random size here. And then all I have to press launch is launch here. And now all of these Honeyfiles are going to be deployed to this system. So Claude Code, LastPass, KeyPass. So let's press launch. All right, so now Velociraptor has gone off. It's done its thing. It's made all those Honeyfiles. So let me just prove that out to you here. Open up Explorer. We're going to go to my user profile. We're going to go into the .claude directory. And you can see, here's that settings.json file, that Honeyfile that I just created using Velociraptor. Now, as a basic, when you're triaging these Honeyfiles, you're really going to get two kinds of detections. One is going to be the threat, two types of true positives, I should say. One is going to be the threat actor using legitimate tools. So let's say they have an RDP session to a compromised host. They open Notepad to read one of your Honeyfiles. It's legitimate Notepad. That's still something we want to know about, right? But also what you're going to run into is the threat actor has injected into something, let's say Explorer. They've injected like a beacon into Explorer, and then they're going to use that beacon to read one of your Honeyfiles in that injected process. So those are the really two things I think we're looking to detect here. And so that's what I'm going to show is we're just going to open up Notepad and let's just read this Honeyfile. So you can see it's all that random data that we bloated it out with, right? But we could make this whatever we want. That magic byte string, you can make that extremely long if you want to just say exactly what this is going to be. But for real quick and easy purposes, we just fill it with random data here. But now let's come over and let's go into our Windows detection Honeyfiles. Let's open up our notebook and let's refresh this and let's see, if we got any event hits. And, right here, you can see 34 seconds ago, we've got Notepad reading our Claude Code settings file. So that worked out perfectly. We get a detection for that. And Velociraptor in that artifact, the file access is such a verbose thing to monitor, but it's going to tune it exactly to the Honeyfiles it deploys and ignore everything else. So it's only going to fire those events when it gets a match. And that's all being done on the endpoint, not in the SIM, because it's so verbose, you really wouldn't want to do this in the SIM, right? So, on top of that, we get a full process call chain. So we enrich that. We can see it's Explorer launching Notepad, which is a nice piece of context there. And we get the thread information, which is something I just added to this artifact this week. And I think it really adds a nice piece of information here to help us triage these events. Because what this is doing is when we get one of these read events from the event trace for Windows source, it's going to have the thread ID that accessed the Honeyfile within that process. Now, the cool thing about that is we can use Velociraptor to see, is that backed on disk? So in here, we can see, what caused it is the Notepad executable in System32, right as we would expect. But what you're going to see in a moment here is when I do that with Sliver injected into Explorer.exe, that's going to come back as blank. And it's going to come back as empty. And that's because we've injected code into Explorer. And that region is not backed by disk. So that's a really nice way we can differentiate between a just legitimate explorer, because there's always been problems with Honeyfiles. Is just opening up a folder like this in Explorer is going to cause read events of your Honeyfile, because Explorer is trying to read metadata, so it can show you an icon here in Explorer. But if we just take this a step farther and we look at those thread details, now I can see, hey, what part of Explorer was accessing this Honeyfile? And we can really differentiate if that was an injected beacon, or if it was the legitimate Explorer process. So
can you do that? Like, do you do that automatically? Luke was asking in the chat, like, how you filter out. It kind of goes back to my question early on, how you filter out normal-ish access. Do you just have a list of processes that you kind of ignore? Do you do like deeper inspection into the threads? I'm curious.
Yeah, great question. So in the initial way I was doing this, I was accepting whole processes, because Explorer was just too noisy that I had to accept Explorer. But now, with this thread details, we don't have to accept Explorer any longer. So we can actually open that up, get our Explorer events, and then back end in the sim, we can say, okay, let's fire a detection if we get Explorer opening a Honeyfile, but it's not backed by disk, the thread, the file name we get back. So you can also adjust the artifact just to do that purely in Velociraptor if you want, so it's happening all in the client, or you can also pull that back and do that in the sim.
Gotcha. So the idea is that if the attacker was RDPing on the box, if they were looking at that folder, you might filter them out because it looks legitimate enough. But then if they open it with Notepad, then you get a secondary hit that isn't. And then
Yep.
Cool.
Yeah, exactly. All right, so let me show here Sliver. So we're running just Sliver, and we're inside the Explorer process, which is one of these processes that opens Honeyfiles all the time. So it's been hard to triage these events when you get a detection for Explorer. And if I just run the PS command here in Sliver, we can see highlighted in green, we are in explorer.exe right now in Sliver. So if we read one of these Honeyfiles, I'm just going to first use this. I'm just going to first do a basic cat read this Azure profile, which is another one of these Honeyfiles we've deployed. We deployed like 15 Honeyfiles just all in one shot. All right, we got back a bunch of random data. Again, we could make this look more believable if we put those exact magic bytes we wanted for this file. Yes, but just by doing this, let's go back to Velociraptor here, and let's refresh this page. And there we go. You can see we have explorer.exe, and we have the thread, the file name is empty, which is a strong sign that we're looking at injected code inside of Explorer that has accessed our Honeyfile. So this immediately becomes much more interesting than if I had just seen this as the full Explorer executable here. So, pretty powerful, pretty cool there. Now, again, there are limitations. Threat actors can do something called module stompings, where they can control the file name here to make it look like something more legitimate, but it's just part of our defense in depth strategy. And hopefully when they do a technique like that, something else in our pipeline catches it. So yeah, I think that's.
And it's a little bit like the initial bytes, right, that you were saying that you can set, because in a way, those bytes aren't there to make sure that the hook works on those attackers, because by the time they've seen the bytes, they've triggered the monitoring, right? It's more, I guess, to make sure that they don't realize that they've been caught and keep them around for longer. That's the intent, right?
Yeah, that's exactly right. But we can also combine it. We can take it a step further, and we can combine it with something like canary tokens. So anyone who's seen canary tokens, really powerful way, deception, free to use. So we can make a fake Kubernetes token here if we want. Now I'm just going to use like a fake Gmail here for our test. I'll say test. Let's download this canary token. All right, we've got our canary token. I'm just going to load it up in CyberChef. So load this canary token up. Let's just format it in hex so that we can use it in Velociraptor. And I could pull this exact content. So now the attacker is going to see, this exact, much more believable data in that honey file. And even if they have some really sneaky way of reading it that doesn't trigger this detection, they're going to trigger the canary token. So all we would have to do is come in here, edit our artifact, configure the parameters, and then we could, just instantly out to our whole fleet if we wanted, deploy another honey file right here, and we would just paste in those magic bytes. And there we go. That honey file would be filled exactly with that canary token now. So now we have like 2 layers of detection going on. So you really can combine it. But yeah, in its default state, you're really just looking to catch the threat actor on that file access. And we make it a little bit larger so that if they do an LS or they're listing the file system, they're not seeing something that's so small that it's not even believable at all.
So with your current setup, have you deployed these to to prod and enterprise environment? What I'm wondering is, how close are you to, how close is that setup out of the box to being viable in most enterprise environments versus it takes about a week to go through alerts every day and filter out stuff. I don't have like a gut feeling of how often that would happen.
Yeah, so the artifact is extremely viable to deploy, but the problem is every environment is different. So in one environment, you might have software that's accessing these honey files all the time, legitimately. Maybe it's your EDR that's accessing them, because when you write a honey file, it does a scan of that file. There could be all sorts of reasons these get accessed legitimately. So there is that tuning phase that you have to go through. But it kind of just goes back to, going back to the basics, know your environment better than the threat actors. And then you can move on to something like this, which can, really be, I think, a low cost, high fidelity detection if you go through that tuning phase. There's also been kind of like a big uptick here in infostealers. Anyone who's been following infostealers, they've been on the rise the last 2 years. And if you go and reverse engineer some of these off-the-shelf infostealers, Vidar, Redline, Agent Tesla, you'll see that they're not all that smart. So if this infostealer lands on someone in HR's computer, let's say, for example, it's still going to go and try to grab their SSH keys, even though someone in HR probably doesn't have SSH keys. So this is a great way to get a detection. And your person in HR is probably never going to legitimately trigger that honey file, because they're not going to know to go to their user profile and open the .ssh folder and open RSA key. They just have no reason to do that. And if they are doing that, maybe that's interesting anyhow, right? But it could be a great way to detect these infostealers because, just frankly, they're not that smart. They don't know the context of the user or system that they land on. They're mostly getting delivered through malvertising. So you can real effectively just deploy some of these honey files that a hands-on keyboard threat actor would probably never access for someone in HR, but one of these infostealers is just going to immediately go and try to grab all of these files it's interested in so it can send it back to the threat actor. So, real kind of nice way to get detection on that as well. All right, yeah, I think that wraps the demo. There's also, for folks interested, there's also the Linux variant here, which I did mention. And in this, super cool, we use eBPF in Velociraptor. Just as a side note, eBPF in Velociraptor, fairly new feature, super cool, super powerful, because it also lets you see the events in any containers that are running on the host, not just the host itself, all for free, just getting that visibility. But that's also what we use to get the file access on Linux. Works the exact same way, but you can deploy it out across your Linux host, fake SSH keys, environment variables, wherever else might have sensitive data, and get detections there as well. Right.
That's super cool. Giving me lots of ideas for sure. So what's the next like what's the next gen of that solution? Or is it in your mind, is it like pretty much kind of feature complete, or you want to keep pushing it? What are you thinking?
Yeah, great question. I think it's come a long way since I first deployed it, but I do want to keep adding just additional context to that detection. So just like we added the thread details, we have the call chain. Maybe next we add the authenticode signature on there, just so you can see if that process is trusted and signed. Just more and more context so that defenders for their environment can then go and tune that and decide what they want to see and what they don't want to see, but just surfacing up all as much information as we can. So as a defender, you can make the best choice possible.
That's interesting. It feels like the other thing that might be useful, though I don't know if it kind of holistically fits in like the Velociraptor workflow kind of thing, is the ability to automatically determine on a specific endpoint which files it should install, kind of thing. Right, meaning like right now you kind of have to go and do the footwork first, and know, okay, we're using KeePass already, so maybe I don't want to try to deploy this. So being able to say, hey, here's my 20,000 endpoints, endpoint per endpoint almost. Look at what the footprint that exists on there right now. Make some like interesting, not guesses, but like heuristics about, okay, this is clearly not a developer. Okay, let's put some SSH keys in there. Let's put stuff like that. Like that feels like that'd be super cool.
Yeah, that sounds sweet. That's a really great idea.
And so, Don, I see a question. It's interesting. So, like, without going like super deep into that, like LC deploys Velociraptor, so we have the ability to deploy through it. What I'm actually thinking is, this sounds like a really great extension in LC land to essentially, I mean, like, I think you have the model sort of perfect into that of like how you set it up. So like that sounds like a really good weekend project.
Yeah, that would be a really cool integration.
Very cool, very cool. Awesome. Any other kind of parting thoughts about, maybe deploying this in enterprise, like tips or like pitfalls that you've seen people hit?
Yeah, I mean, I would just say start small. So choose handful of computers, look at performance, because the amount of file accesses you get can affect performance. So if you have some things in your environment that are different in mine, maybe this runs a little bit hotter than it did in my testing. So you just want to look at that carefully. But we did a lot of work to tune this, to deduplicate it. Big thanks to Matt Green and Mike Cohen, who helped me write the artifact. So I think it's in a really good spot to start using it, but just spend the time to not only make sure it looks good on a performance side of things, but then also to tune those detections so you're not getting, just hammered by detections right away because you might have something in your environment that's accessing these all the time. But on the flip side, it's also a great way to learn about odd things happening in your environment, even if they're not malicious. Just seeing these odd processes accessing the Honeyfiles, you might learn something new about what's happening and what's going on.
Yeah, those are wise words. Start small and learn, but make sure you can survive if you learn the wrong thing.
Yeah,
I
exactly.
love it. Awesome. Well, thank you so much for coming in, talking about this. That was super cool. If folks want to get in touch with you, maybe they've got some ideas, they've got some questions. Is there a better way to do that?
Yeah, definitely. I'm on LinkedIn, so that's probably the best place if you want to get a hold of me.
All
Definitely be
right.
happy to chat about it.
Very cool. Very cool. That's the beauty of open source, right? Too. So
Yep, exactly.
awesome. Thank you so much. And thanks everybody for showing up. We will see you next week on the next Defender Fridays. Have a good weekend.
Awesome. Thanks for having me.